Hey folks, let's see, this is one more in the series of how to use the workbook videos for STT2810. Let's just get started. I was going to do a couple from Homework 20. So these are just the ones I've been emailed about so far. So I'm going to do them to them. All right, so what do we have here? Using t-tables. I've got a t-calculator. I guess that works there. Other ways to do this, but this is the way I like. I want the critical t value for a 99% confidence interval with 16 degrees of freedom. Well, df equals 16, so df equals 16. 95% confidence interval. So first, I want to click on the between version, which I'm already on. 0.99, right? That's the proportion between these two values we want to see. All right, so the area under this curve represents 99% of all of the area of a t distribution with 16 degrees of freedom. All right, and here's our critical value. So I'm going to type in here with 2 decimal places, 2.92. Thank you, Pearson. I know. All right. Lather, rinse, and repeat. This time it's at 98% confidence. This time my degrees of freedom are 51. Bingo, bango. 2.40. All right. So that's how that one goes, guys. Let's see. Do a couple more. This one. Okay. So, let's see. We're building a parking garage. All right. So this is about the city figuring out their income from this parking garage, basically. So random sample of 42 weeks. With standard deviation of 17. And let's complete parts A through E. What assumptions do you have to make? Unimodal and symmetric with no outliers. Sample size, at least, no, not that one. The data are a random sample of all days. Yep, these two things have to be true. All right, so let's find a 90% confidence interval. So first of all, doing it the old-fashioned way, my degrees of freedom are 41 because my sample size is 42 weeks. Okay. My probability I want there is 90%, so that's 5% above here, and 5% below here. Okay, so the critical value is 1.6829. So, how would I work that? I would say to myself, what is 1.6829 times standard error? Well, I don't know what standard error is, right? In fact, I'm going to take the equal signs away. Okay, well, I better find my standard error then. Standard error is equal to, so the sample standard deviation, that was our $17. Let's look back at the problem. So with a standard deviation of $17. All right. And I want to divide that by the square root of 42 because our sample was 42 weekdays. Okay. Hit enter on that and we get a 2.623 blah, 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 blah. All right. So what am I going to do now? Now I can replace this. Equals 1.6829 times this number I just computed right there. Bingo boomo. All right, that's our margin of error. So, what was our mean? Mean 126. Okay, so our confidence interval is 126 Let me double check that number. Ooh, ooh, I don't want to be here. I want to be over here. Check that number, 126 equals 126 plus the margin of error equals 126. Oh, maybe we'll do it right. Plus should go to the right of the minus version. Yeah. 126. 126 multiplied by the margin of error. All right. Minus, right? That's what we're doing. Minus, not times. We've already done our multiplication. That was the t star minus or times the standard error. Sorry about that, guys. There is our confidence interval, guys. All right. Let's throw those in there. 121 points. Here. 121. Two decimal places. 59. 130.41. Well done. Thank you, Pearson. Okay, so before we jump out, there's the other way to do this. So the reason I didn't put this name in the title of the video is because it's a lot. But basically it says TCI within 1 mu. So what is this? This is T confidence interval and hypothesis test with 1 mu or 1 mean. So that's what that gobbledygook comes out to mean. All right, so let's do this problem this way. I want to be 90% confident with a sample size of 42, a standard deviation of 17, sample standard deviation there, and an X bar of $126. I want to see my confidence interval. Well, boom, there it is, just like we computed it by hand. All right, so there you see two kind of ways to go about it, right? Okay. So are we 90% confident that the daily income for all weekdays falls in the interval? Are we 90%? There is a 90% confidence that the mean daily income will always fall in the interval. There's a 90% confidence that the daily income for weekdays falls in the interval. There is 90% confidence that the interval contains the mean daily income. Yeah, that's the best description of those choices there. Okay. All right. Just to be thorough, I'm going to do one more, but let's see. Actually, did I complete that one? Weekdays have daily incomes that fall in that interval. All sample size 42 produce intervals that contain the mean daily income. 90% of all weekdays sample. Okay. Yep. Okay. So there you go, guys. Oh, geez. Okay. Consultant who advises city project. Parking revenues based on your confidence interval. What do you think of the consultant's percentage? Contains the predicted average. It is plausible. Yeah, so the 90% confidence interval definitely contains $124 per day. Yep. Okay. All right. There, we finished it. Okay, now we. All right. Yeah, so here we're given some summary statistics. And the trick with this one is to recognize that even though this is a proportion, it's reported as a percentage, there is a proportion. This is about the mean proportion of flights on time, right? So this is still a mean and still a t-distribution. So how do we do these? There's no reason to assume flights are not roughly independent. For percentage of flying. There's no reason to assume that this is a random sample, but there's no reason to assume that it isn't a random sample. Is it a 10% condition? Yes, definitely more than 72 times 10 flights, right? Yes. Nearly normal condition? Yes. It is not unimodal. It is very roughly symmetric. All right, confidence interval time. This is what we all came here to see. All right, 90% confident again. Now my N is 72. My standard deviation now is 2.48864. This is not the time to round that number. You want to put everything you got right there. My X bar, 80.6250. Enter. All right, just like it says, guys. I could even like copy, paste, and then round to 2 decimal places. So I round to 4, 0.14. I could even control copy, paste, and round to 1. So nice. That's so nice. Okay, interpret the interval for a traveler planning to fly. Yep, there it is. There it is. All right, folks. Well, not to whip a dead horse. That was a little bit of a video. Hope you guys enjoyed watching me read things and prevaricate for a bit before I picked the right answer. And I hope you guys caught on that confidence interval stuff. Another video with hypothesis testing to come. All right, have a good day.